તમે ઓકે.
Jigyasa, you can start.
Okay, so I'm so sorry for starting it very late. Like I joined very late now. So let's start today's tea talk. I'm very excited to introduce the speaker of today's talk. So he's P. Gangadhar Dora sir. So let me like brief you all with his achievements as we already know him very well, but still for the sake of like other newcomers who are there with us. So P. Gangadhar Dora sir is a distinguished professional. Sir, 1 minute.
Can you put your camera on so that we can see you, please?
Yes, sir. Sir, am I visible now?
Yep.
Yeah, go
Okay.
ahead.
Thank you, sir. So, Sir P. Gangadhar Dora sir is a distinguished professional with over 45 years of experience in dairy engineering, cooperative management, and rural development. A graduate in agricultural engineering from the year 1978. He holds a graduate in agricultural engineering, MTech in dairy and food processing from IIT in the year 1980, and a postgraduate training in management from XIMB in the year 1992. He began his career with the direct joining ranks to hold senior leadership roles, including general manager and chief general manager across multiple district milk unions such as Puri, Samaleshwari, and Ganjam Gajapati over the year 1991 to 2016. During his tenure, Mr. Dora led several pioneering initiatives introducing DX and IBT bulk milk coolers and electronic milk testing in eastern India and launching Odisha's first women dairy and turmeric development projects. His strategic leadership significantly strengthened farmer oriented dairy infrastructure and rural livelihoods. Post OMFIT, he served as consultant from year 2016 to 2017, plant head and GM engineering projects at Pragati Milk Products from the year 2018 to 23, where he continued to drive operational excellence. Currently, he shares his expertise as visiting professor at KIIT KIT School of Rural Management since 2023 and the Central University of Odisha from 2024, mentoring the next generation of rural development professionals. So it's my honor to welcome Dora sir again. So you can continue now.
Thank you very much, Jigyasa ma'am. So I think we have got very less number of in the audience side. I think how many so far?
Sir, people will join. Why don't you continue?
Anyway,
yeah.
Because the time is also very limited.
Right.
So we have to go through. I'm really delighted and excited also. I'm thankful to Debu, Vishwajit, Jigyasa, and all others, those who are directly involved in just bringing me in front of others to tell about the dairy industry. We can directly jump into the topic. I have spent, as you know, a lot of time in dairy industry itself, starting from production, collection, filling, processing, quality control, marketing, and every aspect I have seen that. So there I found really I felt myself very proud to be an agricultural engineer, because agriculture engineer, as you know, we are master in every branch. Master in every branch, we used to challenge everybody. And I got the scope of working in all the fields, particularly when I joined the dairy. During our time, frankly speaking, I'll tell you, during our time, only for getting a cup of tea in 1974 to 78, I studied in the college. Only getting a cup of tea in a day we had to walk down almost so many kilometers up to that Unit 1 market. There only one person was bringing milk from that Niyali Madhav route, and he was preparing the tea. And there was a long queue of more than 200 people waiting together just to take a cup of tea. But today the scenario has totally changed. Now we have been in a surplus stage. We have got sufficient milk and we are sending it to outside the state. When you think of the dairy industry towards sustainability, viability, how to, when we are talking about these things, particularly sustainability, making it viable, the dairy industry and the sustainable, three important aspects we look forward. One is towards the environmental protection, that is a essential part of any person who is involved in the food industry, particularly an agricultural engineer. They are more they have been responsible for this, the environmental protection, and looking also to the social responsibility, but without forgetting the minimum essential part is the economic feasibility. It is not only becoming the economic feasible, but we have to also maintain, we have to sustain in that particular position so that our organization can progress and we can cover more and more families, both in producer side and in consumer side. I have seen in my own eyes where there is a difficult position. Many of the dairy industries are also stopping or closing down just because they are unable to follow these essential needs. What we are looking for in environmental protection is the basically I have identified water resources management, energy consumption, energy management particularly, so that we can have a minimum energy utilization, waste management and recycling, and thinking about the economic feasibility we see for operational efficiency improvement, cost reduction, and resource optimization. Whatever resource we have, be it the manpower resources, energy resources, or time resources, everywhere we have to look for the optimization of resources. Then the social responsibility. It is not only the food security. Government is thinking about the food security, but government has also taken very seriously about the food safety. Whatever food we are providing to the consumer, to the people, that has to be safe. And particularly it helps in food industry and in dairy industry in particular. We have to ensure that it is the best quality food that we are able to give, and the quality has to be maintained. Quality assurance at every level, as say S to S, sourcing to sell. Every point we have to ensure the quality and the consumer protection also. There are certain minimum fundamental points in a dairy industry which are to be observed. It is slightly different than other food industries. One is it is a round the year operational plant, operational industry. You cannot stop for a moment because cow will not stop giving milk to you and people will not stop taking milk. So people need the milk and there is the production. So your organization has to run fully. Second is you have to maintain the cold chain facility right from the bottom to the top, from the sourcing till the edge. That is why the moment milk is being collected, first and foremost priority is how to save the milk, to go for the milk chilling. So in our traditional system, whatever we were having, we have found a lot of developments in technological development as well as some legal requirements. There is a lot of developments in there. So our role as an agricultural engineer, as a future industry experts, agriculture engineers will play a pivotal role in designing, implementing, and optimizing the sustainability the drive in the dairy industry towards a more efficient, environment friendly, and competitive dairy 2.0 era. That's what they have suggested. If we see for the regulatory requirements, we can see one. Okay, in the regulatory requirement, earlier it was post-independence era, the act was Prevention of Food Adulteration Act. This was a very old act. It was started in 1954. And after so many years, there were so many complaints, so many compliances were required, but it was not matching with the time. It became anachronous also. So that is why it was decided to go for a new act. And after the globalization, liberalization, when we started exporting the food and we started importing the food, everywhere there was a tremendous stress was given on the quality of food. That is why in the Food Safety Standard Authority of India was formulated. FSI Act was given in 2006, and there were some changes in the milk industry, particularly in terms of quality of milk. You will be interesting. It is interesting to note that when I worked in 1980 in a plant, that time I studied, I was told that cow milk standard was having three different standards throughout the India. One standard, the highest cow milk standard was specified by the PF Act was for Punjab, Haryana and Chandigarh, it was minimum 4% fat. Rest of India, within bracket, except Odisha, it was 3.5% minimum fat in a cow milk. And in Orissa, it was 3%. It was not, the liberal standard was given for Orissa, considering we were not having any quality animals available in our. But subsequently, what happened? We started working cross-breeding program. We started getting lot of cows and the milk from other states started. They started selling in our state. We were also interested to sell the milk in outside the state. That is why a standard was required, and that is why a lot of pressure was given on the government. And finally, government has recently they have conducted a study throughout India, and they changed under FSSI. Earlier, whatever was there, various qualities for cow milk, it was changed to 3.2 and 8.3% SNF. 3.2% minimum and 8.3% SNF minimum. So also there was a standard which was implemented for camel milk. Earlier it was not there. No standard was there. And it has been implemented. There was a change in standard of the sheep and goat milk also. Earlier standard it has been changed. And double tone milk, there was some slightly change from 1.5% fat minimum to it has been brought down to 1.3% fat. There was two important things were done. One was if you are not specifying the standard name in the milk, then they were considering that it is a buffalo milk. You have to fulfill the minimum requirement of 5% fat and 9% SNF under PF Act. But recently it has been changed. It has been told that you can go for standardized milk, 4.5% fat and 8.5% SNF. So they have reduced the standard because PFA was having very high punishment, directly imprisonment. If you are convicted, you will be imprisoned. But in FSI, it has been slightly liberalized, you will be penalized. And the sodium content was one thing which was incorporated now in the Act under FSI, that sodium content of the milk should not be more than 850 milligram or 100 gram of SN. That was a new concept that was given. So there are certain regulations which were brought up under the PFI, and similarly some more regulations were given. One was under the water. There was a board, Central Groundwater Board. The moment you go for construction of a dairy plant and start using the groundwater, they are in a position, they will give you a lot of lists that you have to satisfy to the following minimum essential points, so that they will have a total control over the use of groundwater, how much you are using. For example, the first and foremost point they specify that you have to use digital water meter, tamper proof, and having the telemetry function, so that everywhere, wherever you are using the water, the data will, real-time data will go to their website, and they will be able to know how much water you are using it. You can well imagine the role of an agricultural engineer when we are reading about the soil and water conservation. It is directly affecting in our food industry, particularly in the dairy industry. I have worked for such a long time in the government. There I was not looking for such stringent conditions. But the moment I joined in a private sector, and with me, I have seen other persons from our agriculture like Vishwajit, as Niranjan Senapati, Sandeep Mahanti, there are many people who joined. Subsequently, we found that the conditions in private plants are very precarious because there are so many inspectors they used to come and visit. So groundwater we have to monitor. Then second, they specified that there should be a piezometer, a dedicated borewell, tube well, where a piezometer will be fixed, and it will give a indication what is the water level available. Because if you are seeking more water, the water level will go down. It will immediately send a signal to the groundwater board over their website. They will immediately catch it. So they will give you permission that what is the quantity of water you can extract from the ground and use for your plant. You cannot extract as much quantity whatever you require. So within that they monitor that. Third is they say that quality of the water is to be tested every year in a particular month, and that has to be tested in the National Accreditation Laboratory. You cannot test anywhere else. And that report you have to send again over the mail or on the website you have to place, because they want to ensure that whatever water you are using, it is of the good grade, good quality. Fourth is you have to go through the annual water audit. That is necessary, and they have specific auditors who will visit their plant at a regular interval to check how you are consuming. And next, they have also identified the rainwater harvesting system you have to have in your plant, so that whatever you are extracting the water to some quantity, at least you can use it from the rainwater for your work, and extraction can reduce. Next, they have also told about the plantation program. You have to go for massive plantation in your plant campus, so that you can preserve the groundwater also and control the pollution. They have specified minimum 1,000 plants per acre that has to be planted in the plant. There are so many conditions, about 50 conditions are there. I have identified only the selected conditions set up by the Central Groundwater Board. Similarly, there is the board, Central Pollution Control Board. They have also given number of different controls how you have to operate the plant, because they used to give you two consent. First consent, they will give you the consent to construct, and after you construct the plant, they will give you another consent to operate. In both the consents, they will give you a list of long conditions. Like one condition is the minimum quality standard. They have specified more than 20 different parameters with different quality standard. You have to stick to the standard, and the standard also they are making stringent day by day. Because when we started working in 1980, that time the standard was EOD of that particular effluent, the biochemical oxygen demand of the particular effluent was much more. It was subsequently restricted that it should not increase more than 100. As on today, it has been made so much stringent that it will be within 30. It cannot go more than 30 in any. It should be less than 30 million, uh, 30 ppm, parts per million. This has to be maintained. So for that also, new technology we have to introduce, we have to incorporate in the plant. Very recently, the new technologies have come up, which is helping to reduce the yield. So how we are doing that? Effluent quality standard they have specified. The flow measurement at different places, mandatory flow measurement, deep through pipes, valves, drains, everywhere they have specified. Sludge management, whatever sludge will come out, it has to be dried and it has to be sold, it has to be utilized, or any wastage is to be removed totally from the plant area, from that area. So these special, and besides that, they have given a standard for air emission also in the boiler, whatever fume it is coming out, it should not have more than 800 mg per annum square. The regulation they have specified that it has to be within that limit only. Then the ammonia safety, they have specified a safety how you will keep that also they have decided and they have specified. Now for noise pollution, you have to go for earlier whatever generator we are using. Now it was told that we have to go for individual acoustic enclosed and soundproof generators, and for all sound making machines you have to have soundproof areas, so that you will reduce the sound pollution also. Similarly, mandatory green belt, as I told you, plantation of different trees, and what are the different type of trees, that also they specify. The fire safety system, you have to have a hydrant system in your plant. It is mandatory. Hydrant system, that fire officer will come and check. You will have to have separate water tank, dedicated water tank for emergency requirement of fire. And you have to have two pumps. One is a electrically operated pump, second is a diesel operated pump. Because they say that due to some reason if the electricity is also burnt out, then you have to operate with the that is why all these systems you have to follow. You have to keep a gap all around the plant so that on emergency their vehicle can move. So there are many restrictions that have been made under the fire safety. When plants also there are number of restrictions. So all these regulations we have to see. And if we come to the milk part particularly, if we see in the starting from the milking stage, earlier it was only limited to hand milking. We introduced the machine milking by milking machine earlier that was not there in Odisha. It was introduced somewhere in 2002-3. That time it was introduced in some of the big farms. Then, as on today, Odisha is also having very big dairy farms who are having milk parlors. At a time, 2, 3, 4, 5, 6, up to 10 cows can be milked, which was there earlier outside. In India, it was very limited was there, but nowadays in dairy industry, you'll find most of the big farms, they are going for the milking parlors. And if milk collection and testing, particularly the quality, earlier it was limited only to the quality of lactometer reading. But how dense the milk is, what is the density of milk by use of lactometer. But afterwards, the milk tester came up into the picture where the milk was taken through the milk tester to read the sample, light will be there and it will give an indication what is the fat percentage in this. Subsequently, the recent trend is we are going for the milk analyzer. Earlier, first it came only fat and SNF reading of the milk. Subsequently, it started giving the fat, SNF, the protein, carbohydrate, and added water, etc., etc. Many things also you can find out from these things. But at the society level, they are normally going for this milk analyzer, which will give you a figure of what is the fat percentage and what is the SNF percentage in the milk, because these two are the parameters on the basis of which the farmer is going to be paid. The rate is to be calculated and he will be paid for the quantity of milk given by it. So there are certain technological changes. The current challenges are traditional milk collection method was involved significant time between milking and cooling. Cooling is an essential part, leading to bacterial growth, quality degradation, and increased rejection rate of milk. So what happened first? They took up immediate cooling, on-site cooling directly at milking line. According to to avoid the contamination, you can see in the picture also the milk vacuum milking machine. They are placed with the cows. Whatever milk will be removed, that will be passing through an instant milk chilling unit. Then it will go to the bulk milk cooler. Milk chilling unit will be cooled down, and these are the latest technology. In the big farms, they have started implementing such type of systems. Then it locks the freshness and quality from the sources and prevent the bacterial growth during the critical first few hours. Then we went also for the automated collection system. You'll see very interesting automated collection system. Initially, we had a system of only the collection through the auto milk analyzer and fat testing machine and on the volumetric measurement. Subsequently, a time came when we started having all these machines available in the milk collection point. You can see in the picture, there will be a weighing machine. The moment the farmer will give the milk, it will be weighed, it will go to the CPU. There will be a machine for testing the fat and SNF. There will be a machine for printing the required calculation, making the calculation and printing whatever quantity of milk he has given. And then the entire figures will be passed through net to the central server of the milk union. Milk union will find out exactly which person, how much quantity they have given, what is the quantity of quality of milk, how much money he will get. And they will be having the database. They will send the entire figures, the payment figures to the bank, and from bank account that will directly go to the farmer. So farmer, instead of waiting for 10 days or 15 days after giving milk to know exactly how much money he's getting, nowadays the development has become to such a state that the instantly he's pouring the milk into the collection point and he's getting a message, SMS over his mobile that how much quantity, what is the fat, what is the SNS he has supplied to the society. And by the end of the day, he gets a figure over SMS that how much money has been deposited into his account after deduction of the cost of capital, cost of other technical input materials. So this has been a lot of improvement, technological improvement through this particular system. So there is an automatic milk collection system, and then we have gone for the milk chilling system. That has been chilled earlier. There was a system of centralized chilling at a in a block or in a subdivision. We are having a chilling, and we were having the milk unit in all around different places. It was passing different village, and it was collecting the milk. By the time milk reaches to the chilling plant, after the milk is milked from the cow, there was a gap of more than 4 to 5 hours, which was the reason for which the bacteria was developing very fast. But nowadays the system has totally changed. Now earlier there are limited number of milk chilling plants were there. Now as on today you will find more than thousands of bulk milk coolers. Small bulk milk coolers they have been placed in different villages where the milk is being collected. Immediately after pouring into the tank, it will be chilled. It will be gradually cooled, and within 2.5 hours or 3 hours, it can be brought back to 4 degrees Celsius, which is the safest temperature for storage of milk. So number of bacterial enhancement has gradually reduced, and finally, whatever quality of milk we are receiving at the plant, that is the main point. When we get a better quality, if we are getting better quality, we can give you better quality of milk and milk products to the consumers. That is why it was also discussed in the government of India. They have started reviewing that what was your earlier SPC count, what was your proliferation count in your milk, and how much you are getting now. What was earlier NDRK timing, quality parameter, what is now. So everything is in, and there has been a lot of change over a period of time because of introduction of many new parameters, many new testing equipments and testing methodology, the quality for there has been a lot of development. So this is the auto system using for farmer payment, etc. And if we go for some engineering items, particularly whatever last in Odisha I have seen, I have not taken look about the outside. Within Odisha, we have seen one important technology they implemented recently is a bacterial fusion technology. It was not there. I was not knowing also earlier, but later on it has come to our notice that when you are going for a high quality milk, like a Tetra Pak milk or UHT processed milk, also high temperature processed milk, a good quality milk. You need a better quality milk having a less spores of bacteria in that. And that is very difficult also to get it. But they are using centrifuge machines, particularly for centrifugation. They are using such type of machine and in one, not in one, single stage or double stage machine. After during the pasteurization, whatever clarification we are doing only to take out the sediments from all around and taking out either the cream or milk from the center. Now this centrifugation machine will eliminate all the spores of bacteria that will physically they will eliminate, and the bacteria content in the milk will come down drastically. This we have seen in the Bhubaneswar, the new plant which has come up under Omfed. We have found the Tetra Pak they are making and they have installed this machine. So this bacterification technology has already been incorporated in Odisha. And they have many new sensors have been utilized at 50 places at different locations of the plant. IoT based monitoring process has been there where you get the real time data for every activity. I'll give you a very small example. In a chilling plant, you have a milk tank. Earlier, we were not knowing who is removing the milk from it and who is adding water into it. But now they have started putting the load cells of the below the leg of each tank, and that will be connected to a centralized IoT system based monitoring point. Then you are going to get the information over web in your mobile. So you can be able to know exactly how much milk has been collected, whether how much milk has been supplied, what are the milk is there. If there is anybody who is tampering, that also it can be detected then and there itself. So this has also been started experimenting or putting into use in our state by different dairies and different places. Then ERP implementation. This is one important thing which has taken place in dairy industry. Earlier, when I visited long back, they started introducing in Gujarat, Kerala, all developed state. Now it has already come to Odisha. There, what happens? Every point, everything is being connected to the different to a central server. All the information is going there. So repetition work gradually it has reduced. Earlier we are having all recording manual recording system. When somebody is bringing a milk, it has to be recorded at the security gate. It has to be recorded at the collection point, at the reception point, at the quality point. Everything was closed together to one central server. Once it has been entered, everything is available. The accuracy has increased. Fast, the timing has reduced, the swiftness has increased, and ERP not only in collection but also in processing, then in marketing. Marketing also it has out. So this ERP system has already been implemented in some of the most of the developed dairies, and very few small dairies they are not implementing, but all the developed dairies they have already started implementing. Then besides that, there are some packaging innovations. Then in one in our Tetra Pak, we have noticed a new system came earlier. Pre-filled pack machines were packets were there. The containers were coming Tetra Pak containers. There it has been filled and sealed. But now earlier it was a roll system. The roll system was formation was there and it was sealed. But later on it has already come. The existing packets were there. So that is reducing a lot of wastage of packing materials as well as wastage of milk. Second is increased film thickness. Government made a restriction. Earlier, we were using the milk polythene film to as low as 38, 39, and 40 micron thickness. But government set up a minimum standard of minimum 50 micron thickness. You cannot use any polythene below that. That is why ultimately this was changed. Though we have complied, or dairy industries are required to comply to the government regulations, but it also helped in one way that the sealing was proper. Earlier in the low film, the sealing was not proper. Second is we introduced an anti-foam system in the milk line. Because earlier, when this system was not there, in most of the dairy industry all over India, I noticed they were having a complaint that there is a huge amount of leakage in the packets, the polypack. After production, the leakage was going to the extent of 10%, losing heavy amount of milk as well as polythene boards. But they introduced a very simple formula. It was discussed in the Indian Dairy Industries Conference, and a solution was given that you have to utilize some nylon strainer system at the injection point of the milk. So which will reduce the foam drastically. And once the foam is reducing, the leakage will reduce. We have noticed that the leakage came down to as low as 0.5% also. You can imagine from 5% to 0.5%, what a great quantity of milk and polythene rolls have already been saved. Similarly, there was a system of we were using the homogenizer, there was a pasteurizer. When homogenizer was pumping the milk into the pasteurizer, it was a reciprocating machine. So pulsation system was there. That is why the pasteurizer was unable to take the load. And after working for some time, it was injecting out, it was bulging out. The milk was flowing out. Then a testing a system was checked up why this problem is coming up. Later on, we could find out that this is a problem. A senior person from Mother Dairy he came and he pointed out. Then we put an air pocket on the discharge line of the homogenizer. What happened? The fluctuation load it was absorbed within the air pocket, and milk started flowing uniformly through the pasteurizer. So that problem is avoided. There were many problems which have been gradually avoided because of using some technological items or technological development.
Sir, you
Similarly,
will have to
in the
complete
engineering
quickly.
in the
Sir, you
engineering
will have to
resources we
complete.
have okay. In the engineering resources, you can find I have shown a picture. Earlier, we had a big ice bank tanks in for chilled water, which has to be used. Later on, it has already been changed to the system of ice silo. Within a small space, you can go and you have the ice falls within the site. We have replaced the system of the reciprocating compressor to the through compressor, which was reducing the energy requirement by about 15%. Then this other cold storage technology is within that we have seen there was a lot of space was left within the cold store, even though we were having the scope to cool, but it was not possible. Now the new system and new technology has come where you can roll the entire cell along with the milk through on the rolls, and you can utilize the entire space within the cold store. You can also load the packets directly from the cold store into the truck through certain automation system. So there were some then newly recently we are also utilizing the hydroflow system. Hydroflow system is a system you pump the water and the entire pipeline will be under pressure. When you open a particular place, pressure will come down, then only the pump will open. The moment it will be having the sufficient pressure within the pipeline, the pump will stop. So this was a hydroflow system which is also being used. And for the effluent treatment efficiency, they have a system of using the diffuser, the air diffuser, completely high pressure diffuser. It was diffusing the air to the extent of less than 0.1 micron, by which actually the BOD was drastically reducing. Earlier it was difficult to get it BOD less than 50. Now it is coming even less than 25 very easily. Only capital investment was there. So these are the some the ETP plants earlier even it was considered as a wastage plant. There is a loss plant only because of the legal regulation they were doing. But now it has already changed to a profitable plant because whatever extract wastage they are getting out of the ETP that is being sold and they are in a position to maintain that. So this is the new technology that's come up. Under the cold chain management system, we have got the cold storage facilities as well as cold transportation facilities where you can always see earlier this system was not there. Everybody was having the milk in the open truck, sell of the milk. But now these things have been focused for the quality, monitoring quality. Then there are certain other industry transformations are also there. The if we see this for the agricultural engineers, you can see it's a rightly a path forward for different things. We have to have developed technology for maintaining our improving our efficiency, reducing our cost, and sustainability. Basically, to sustain the role of agricultural engineer is a very important here. As a pioneership change, agricultural engineer should acknowledge for proper design, proper implementation, and proper management in the dairy system to do this. Thank you. This is what I have to say. If we have any other queries in the presentation, we can ask.
Thank you, sir. Thank you. Very excellent
Sir.
presentation. Actually, yes, GV Rao.
Uh, Good evening, everybody. Sir, I have a small question. In a lot of places, are you able to hear me?
Yeah,
Yes.
I'm getting it.
Yeah. In many places, we have milk supplied in bottles. Here, we only have polythene, and there is a concern about microplastics and stuff. So, why aren't we supplying in bottles in India?
Because in 1990 when we first joined, that was the time when the bottle supply system was gradually phased out. Because earlier the system, when you are supplying in the bottle, 3, 4 problems were coming up. One is you cannot use and throw the bottle. You have to rotate it. So you have to supply in the bottle and get it back, again wash it properly. If you are unable to wash properly or examine properly, there are chances of spoil. Second, this new polythene was introduced that time. Polythene system was introduced, which reduced a lot of problem, the manual requirement, the transportation and distribution problem, the washing problem, everything. So it gradually switched over to that polythene. But rightly you have told, a time came when people started talking about this plastic, what we are trying to, government is also taking a serious step on plastic. So switch over from plastic, a new Tetra Pak system started entering into the picture. But again, the cost of question, the cost parameter become maximum because our polythene packaging in a milk in a polythene packaging, whatever was costing the packaging cost, in Tetra Pak case, the cost became many times more. The cost of, I know that time our milk packet was costing 1 liter packet, it was hardly costing about 15 rupees, but the Tetra Pak was costing about 25 rupees. It was many times higher than the price, so it was only targeted for the high consumers. But subsequently, a third system came up, which this used Tetra Pak fiber pillow, no, polythene fiber pillow, the aseptic fiber pillow, they say AFP. It was a very thick polythene and biodegradable also. Normally, it could be used without any problem, and the milk can be stored up to 15 days. Because particularly in the year, and now as you have told rightly, now most of the industries have started using the polythene, and it's very difficult to replace it instantly. Wherever the people are interested to go for the Tetra Pak or other biodegradable product packaging system, the cost is obviously going up. And in India, as you know, milk is a low involvement product. Very low amount people used to pay. So when you are giving a milk, even at a 2 rupees less, that will fetch maximum in the market. So that is one of the reasons why we are unable to eliminate completely this polythene packet system. But the other new packaging systems are also coming up. You have rightly pointed out.
Sir, but cold drinks are still being supplied in glass bottles at an MRP of 10 rupees. So I think all the logistics and all that stuff wouldn't cost more than a rupee or 50 paise for them if they are supplying the bottle of cold drink at 10 rupees. So why do you think it would increase drastically for milk if we supply in glass bottles? Maybe you can, a bigger size quantities can be proposed in bottles or something like that.
I am talking exactly to that. That's a requirement of milk is a thing of half liter or 1 liter. You have to go
Okay.
for a bigger bottle. But in the case of cold drink, where you have seen the bottles, they are used and throw type of bottle. Even milk also, we are using 200 ml bottles. So
No, sir.
sterilized. Milk
Cold
sterilized.
drink is not being used and throw. They are recycling the bottles. I mean, they are taking back and again filling it. That there's a 10 rupees glass bottle which is used repeatedly. That's what
I
I'm
know that.
finding.
Okay. But I'll tell you, sir, please examine the percentage of expenditure on the product itself as compared to the consumer rupee. If you see, in case of milk, we are getting it is having very within the reconstitution. They are able to give a lot of margin to the.
I think he's freezing.
Yeah,
The farmer.
I have it in it.
JB, if I may supplement what Mr. Dora was saying,
Yes, sir. I
in
was
case of
interested in the I was interested in the additional cost that would incur for
yes,
the
yes, yes,
use of
yes.
glass
I'm
bottles.
coming to that only, JB. I'm coming to that, JB. See, in case of beverages, cold drinks, or the cost is in the logistics distribution logistics only. The cost of glass bottles going to the market, returning back, that is their major cost. They don't need refrigeration. They don't need the product itself is not very costly. You obviously you understand that. So that
Yes.
is the reason why they are and because it's a traditionally sold in glass bottles, they are continuing. But even then, when you see these PET bottles coming in for beverages also.
Yes.
Okay.
Nee, sir, I was interested in how much would it cost more. I mean, if we supply 1 liter in glass bottle, how much
Okay.
would it cost more? 1 rupee, 2
I
rupee,
don't
5
think
rupees?
Dorabu. I have not done. If Dora was done any analysis
No,
on the cost part of it, I don't know. But I
no,
don't
no,
think
no,
he.
I know, I
he-
know. I know, I can tell you, we are giving use and throw type of bottle for flavored milk because we have taken the cost of bottle within that. These are 200 ml bottles. So we are not taking it back, flavored milk. But these big bottles, when you are taking, even if you consider 1 rupee or 150, 1 rupee also you consider, actually the margin of milk per liter of milk, the margin is hardly ranging between 10 paise to 50 paise. It is not more than. I have made a lot of calculation. Maximum you can go up to 1 rupee margin in a milk if you do so many manipulations and this stuff. So that if you are giving only in terms of bottle itself, then the margin is gone. The packaging cost actually is coming less than 50 paise per
No,
per pack.
I'm Ramkrishna Das, Ram speaking. Actually, I have seen some companies in India. They are they are delivering milk in bottles, like dairy milk in Delhi. Sorry, Mother Dairy, and some flavored milk. Obviously, they are selling. They are distributing. I mean, packing in bottles. But raw milk also. Some places I don't remember exactly. Some companies are there who are using the glass bottles.
Well, I tell you, there was when post-independence government of India wanted to develop dairy. So that time they started some milk scheme, Bombay milk scheme, Delhi milk scheme, Qatar milk scheme, this type of scheme. There the system was incorporated only through the glass bottle. And the bottle washing machine and all the systems were there. So glass bottle will be given to the consumer, right, and empty bottle will be taken back from. So there was a system which was going on. It was gradually been reduced. But till today, wherever the schemes are there, in West Bengal, you will find the cooperative is there, the Calcutta milk scheme is there, the private dairies are there, then other this thing is there. Except in milk schemes, some of the places where the bottles are still going on because government is supporting that. Government is giving compensating whatever loss is there in the operation. Particularly in those steel items, you will not find this in any of the dairies or private because they are concerned about the money. So where you are getting this thing, you can get it. But in Orissa also we are getting the milk. Now I told you in last meeting, the milk of 200 ml, everywhere you will find this system is there. So though Umphad milk or Pragati or many other places I have seen, it is still in the glass bottle they are giving because if you want to go to PET bottle or plastic bottle, your volume has to be very high. Then only you are in a position to make.
Sir,
Yes, sir. Anything?
my opinion on this is counter to what you're saying. Like you said, 1 rupee
Yes.
is a substantial cost, which is
Mm.
not actually because the brands available today vary up to 3 rupees for a half-liter pack. Keeping that aside, what I would say is if you put a glass bottle milk and raise 5 rupees, even 5 rupees the cost, a lot of people will buy and they will consider it a premium product. That is my just opinion. But anyway.
Yes.
Thank you, sir.
That's 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 good. It's a good suggestion. For some industry, they can still think of as you told, it will become a premium product. Like our Jharalai dairy in Gangadhar, they are supplying the milk in Bhubaneswar. And because their quantity is very less, they are also supplying glass bottle. I have seen that. It's going on some places.
Let me divert the discussion towards engineering and technology because cost is something that agricultural engineers don't control necessarily. Am I right, Biswajit?
That's true. That's true.
Yeah, but I think if there are questions on engineering and technology, that I think Dora Babu will be happy to respond. So, any questions on that? I have a question. What is SNF? I have no clue.
Very, very well. Actually, in the milk, you can segregate into three different parts. First one is water, second is total milk solid. Water is
Okay.
approximately 86 to 87% is water. Rest is the total milk solid. This total milk solid consists of fat, protein, carbohydrate in form of lactose, and the vitamins and minerals. So
Mhm.
all those items get together, it becomes the total solid. Out of that, if you remove the fat portion, then the rest item becomes solid, not fat. SNF,
Oh,
solid, not.
solid, not fat. Okay, okay.
Yes.
I have another question. When you are chilling it instantly, the milk,
Ah,
during production, uh, doesn't it affect also the lactobacillus in the milk?
no, actually, it is a design system. We are right from the beginning. Everywhere they say pasteurization means basically heating to a particular temperature and then immediately sharply reducing it to 4 degrees Celsius. You don't give them time. That is just to avoid growth of the thermophilic microorganisms. There are three different types of microorganisms. Some will survive at the high temperature, some will survive at the low temperature, some at the middle temperature. So when you heat it at a very high temperature, most of the other bacteria they will get killed. The high temperature, the thermophilic bacteria, that will get killed once it will come down to low temperature. That is why it is sharply being brought down. But the other part, as you are saying, how it is going to affect it, I'm really sorry. I've not gone into detail, but nowhere it is. It has been brought up also.
Yeah, that was kind of when you said we instantly chill, and I can understand for other bacteria, forms of bacteria, that we can
But
chill it
I
and
was mostly particularly thinking about
Um,
the milk
Dora,
collection.
if I may come in. Actually, when we are chilling the milk, it is not to kill the bacteria or impact on the bacteria. It is only to arrest the growth of the bacteria.
right,
That
right.
is why
No,
it is
that I
killed
understand.
immediately. Yeah, and the
Inactivated.
lactobacillus is a mesophilic bacteria. So it grows at around its best growth is from 35 to 42 degrees centigrade. So
Mhm.
that also gets dormant in when we chill it. And lactobacillus
Inactivated.
actually works on is the bacteria which creates the problem for us because it acts on the lactose and forms as lactic acid. So that is the target bacteria that we look into when we are chilling the milk.
But isn't
Or when we are
lactobacillus
pasteurizing the
good?
milk. Yes.
Isn't
Another method.
lactobacillus good for our gut health?
Yes, it is good for our
Yes,
gut cell,
yes.
and it is available in curd. That is why
Uh,
curd is
third is,
supposed to be probiotic.
uh,
But then to manage the shelf life of milk, we have to make this lactobacillus dormant. It is
Mhm.
available, but if you heat the milk back into let's say 35 40 degrees, you will get that lactobacillus.
Mhm.
actually the main
Okay.
intention of pasteurization is you reduce the rest of bacteria by 90 to 95%. You eliminate only 5 to 10% will be remaining. But you eliminate completely the pathogens, all harmful bacteria. Entire thing like E. coli and other harmful bacteria will totally be killed. That is the intention of pasteurization.
Correct. Well, they're not eliminated. They are actually made dormant also by chilling, instant chilling. And of course, through pasteurization, then later on they will be eliminated. That I can understand. But the other question that I have is the heat index is increasing in India due to the climate change and other stuff. So dairy farmers that are actually you know, large dairy farmers that have 10 cows, as you are saying, being milked, do they provide, does milk industry look into how they provide ventilation to keep the cows, cooler during summer so that the production is optimized?
Yeah, it is already there, no?
It is there, the
Uh,
ventilation.
it is already there. These are big. You first of all you can see that all the dairy farms, wherever they keep the cow, the prime activity we are saying that you can't have closed rooms. You have to have only 4 to 5 feet height walls all around, and it has to be completely air and light. Both the things have to must be done. And second is in dairy farms they used to put big fans. And I have seen in most of the farms that are done, and wherever they have not used the farm, I have got an experience in Aladina near Purushottam. The person he kept more than 200 cows. He came one day rushing to me, sir, I don't know why but my cows are dying one after another. I immediately rushed to the spot along with CDVO, Chief District Welfare Officer, and we could not enter into that cattle shed. It was so hot. Then they asked, what are you doing? You are killing the cows. Why are you
Right.
keeping the cows within this building? So, sir, it was an old rice mill. It was lying idle. So I have converted it to the. I said, if you immediately engage the labor and make some holes on the top of the walls all around. The moment it was done, the temperature drastically reduced from 3 to 4 degrees Celsius. What the fellow has done to cool the cow, he has put some ceiling fans all over. So whatever heat is being generated from the cow, it is going to the cow, and again it is coming back hitting to the cow. By
Mhm.
for which reason the temperature is going so high and the cows are dying. This is one of
Yeah.
the reasons everywhere we have been insisting that whenever you are going for a cattle shed, you have to ensure proper ventilation. That is one. Second aspect, actually, as I was telling you, that this 80-degree condition of India is a high temperature zone. That is why industries have already taken up temperature of pasteurization to 80 degrees Celsius. Mind it, Louis Pasteur has not recommended 80 degrees. The initial temperature recommendation was 72 degrees Celsius for 15 seconds. That HTST pasteurization. But for Indian condition, the condition of this area, this side, all the industries are now following the temperature of 80 degrees Celsius only to reduce because initial bacterial will be so high as compared to forage. That is why they need a higher temperature to kill the bacteria or the both the things.
Thank you. Thank you. Any other questions for Dora Babu?
So I have got a question.
Each.
Sir, actually, I have been in the milk producing states. Like I, for my masters and my for my PhD, I was in Gujarat, Anand actually. So it is completely a cooperative based milk production factories there are. And coming to Rajasthan, those here also it is having like good quality of milk. Like when earlier in like Odisha was not able to conceptualize the concept of cooperatives and like collecting milk, that time all these states were already having it. So currently the situation of here, like I am presently staying here, and in Odisha I can say that the policies of cooperatives is kind of very well going in Odisha. Like if we are developing and if the cooperatives are going on very well, we can progress in that. But what, like after 50 years of working in cooperatives here in Gujarat and Rajasthan, those policies of cooperative is actually failing. Like they have become segregated. Amul is not working in Gujarat as we say in other states. And coming to Rajasthan, there is a cooperative of Saras. So Saras is also not working that much. So the cooperative concept is declining. So as if we are envisioning for cooperatives in Odisha, sir, how can we like to make the system sustainable? What should be our vision be like for the future entrepreneurs or for the other R&D people also who are working in the cooperative based societies?
So very nice question. Many times you have come across. But I'll tell you one thing. If you go to the history of dairy development in India, the first dairy development was started in Gujarat. How it was started? There is a story. You must be knowing about that story. They say it is their own story. How the people suffered because they were not having any other type of income. They were mostly concentrating on this keeping the buffaloes and buffalo milk they were selling. So they were facing a lot of difficulty in disposing of the milk. That is why what they did, they contacted their leader, Sardar Vallabhbhai Patel. They started thinking of a cooperative, this, that, all systems. And gradually, first two cooperatives were started in around Anand. Then gradually it increased. Then they became Anand Milk Union. Then they also had Mehsana Milk Union, other milk union. Finally, it went. So you can see it has bottom top approach. The farmers were having a need, so they fought together. They started forming cooperative. No government was there. Until today, they are fighting against the government. If government is nominating some person to the cooperative board, they are going to the Supreme Court also to fight against that. They are saying that we are the farmer, we are cooperative, we will not take any assistance from the government. We will do our work and our cooperative will come in a business. But in all the places wherever it has been implemented, take the example of Orissa. What happened? We first started a milk federation by government. When the federation was formed and the four milk unions were registered and some staff were put, they were asked to you go to the village and start accumulating, explaining about the cooperative system to the farmers, make a cooperative. This became a top-down approach. Then all the farmers that started believing that this is a government organization, it's not a farmer organization. You can see in Gujarat, they always talk about this is a farmer organization. Whatever profit in the cooperative, that will go to us. But here, in case of India, everybody is looking for how much money we are going to get from the government. Initial formation, the government started giving help in the cooperative. So this is a basic reason what I have found within my 40 years, what is the basic difference between these two cooperatives not going equally? Because they have already gone to a stage, we could have easily gone to that stage, but it was very difficult to convince the people. Everywhere the corruption, politics, the village, yeah, everything was there. Within that, we have started supporting. One thing we could make that only the farmer who is having a cow or buffalo and he is giving milk to the society, he can be a member of society, others will not interfere. Only because of that, this cooperative system in very cooperative system has started. You see all of the cooperatives where there is a problem, where people have other interests, that has become a problem. But anyway, nowadays the cooperative system has been changed. Even NDDB is promoting the company system, farmers group. They are not looking for cooperative system. In our Odisha government also, they have started implementing so many other things that the farmers will be given the system, this assignment, that assignment, the through cooperative they will be given. I don't know what is going to happen. Our Vishwit will be the best tell because he's already in the field. I retired 10 years back. I know what are the Vishwajit, are you online?
There, sir. Uh, I was actually looking at the time. We'll have to stop
Ah,
now.
yes,
So
yes.
we have
Close it.
overrun
Stop
by
it.
10 minutes already.
No. No, no, but she has raised a very good question. But problem is nowhere the cooperative is progressing except for Gujarat. They are in all the states now. Gujarat has started it. They become so they have already gone to the United States. They have started their own plant and started.
But within the state, they don't operate with Amul. Like within the state, they have other like individualistic approach, like a Chachwala is there, or like other brands coming up. So very small brand that is working in Saurashtra region, then Vadodara, and coming to that Navsari region, they have like four segments. So like that internally they are not operating. They have exported it, like they have extended it. But when we come to Omfed and others, what we are actually looking is we are flourishing in our state. So there is like I think that we can do development in that, and also some value added products, like if you are going for millet also, millet based vegan milk also, like Amul is working on this vegan ice cream and stuff. So yes, we can think for other aspect of working on this.
Everything is going on. We have to also look for the economy of scale of handling. How much quantity excess we are getting on which it will be economically drawn. That's what everybody needs.
Thank you,
Okay,
sir. Thank you, sir. Thank you, sir.
thank you very much. Okay, thank you. I think there is no more question.
Let's conclude. Biswajit, you can, or Jigyasa, you can conclude by stopping the recording. And thank you, sir. It was a great presentation. Thank you very much.
Thank you.